Okay, today we're starting our new unit, Unit 8, which is about solving quadratics. And the first way we're going to solve quadratics is by factoring. So going back to Unit 6b. So remember, we have standard form, and then we have factored form, which is when you divide the greatest common factor out. So this would be like g of x equals 3x times x minus 4, because 3x times x is 3x squared. 3x times negative 4 is negative 12. Okay? And then we would have a solution set. So remember, we have roots, zeros, x-intercepts, and solutions. And when we write these solutions, we're going to write them in these fancy brackets because we don't want to confuse them with a point. Or, and this is going to probably be most common, we're going to write them as x equals. Okay? Now, the factors of G, that's these pieces right here. That's this piece and that's this piece. So they are 3x and they are, I'm going to go ahead and separate it with like a colon here. They are also x minus 4. Those are our factors. So one thing we do want to keep in mind is way back when you first learned multiplication, you learned about what's called the zero product property. And the zero product property basically states that if A times B equals 0, then either A is 0 or B is 0. Because if one of those is zeros, it doesn't matter what the other one is. It is automatically 0. So if we're looking at this, we're saying, hey, we want to solve this. But remember, this is equal to 0. So therefore, I could say, hey, if x plus 3 equaled 0, then I would subtract 3 over, and I would get x equals negative 3. So that if I inputted negative 3 here, that would make this 0. I don't care what this is because 0 times anything is automatically 0. So that works for one of these things. So that's one of our answers. But what if the other one was set equal to 0? So I could say x minus 6 equals 0. And then again, I can do the exact same thing. I'll move 6 over. This becomes positive 6. This means x equals 6. Therefore, if my x value was 0, then this would equal 0. And again, I don't care that 6 plus 3 is 9 because 9 times 0 is 0. So when we are solving for quadratics, we're setting these equations equal to 0 because remember these whole roots, zeros, x-intercepts, and solutions. What we're doing is we're trying to figure out what the x values would have to be in order to make this 0. So we're going to end up with two answer choices. And if you were to graph this, you would have a parabola. You would go over here 1, 2, 3. There would be a dot over here. And we go 1, 2, 3, 4, 5, 6. And there'd be a dot over here. And there would be a parabola that would go something like this. I don't know what the vertex would be. But the x-intercepts right here and here would be negative 3 and 6. So let's practice some of these. Again, this is set equal to 0. That's my first thing. Then I would have to say this has to be one thing, x equals 0. Well, do I have any math to do with that? No, it's x is equal to 0, it's 0. Then I also move this over here, and I say, okay, x minus 5 equals 0. Now I'm going to have to do some math. I move this 5 over. This becomes plus 5, therefore x equals 5. Therefore, my roots are zeros. Again, I would write these in brackets. Would be 0 and 5. Or I could say x equals 0, comma, 5. Okay, let's look at this one. This one we're going to have to do a bit more math with. Here, I'm going to set this equal to 0. You see how this is f of x? I'm going to just change that to 0. Okay, so I'm going to go ahead and do that. I'm going to have 2x minus 5 equals 0. Okay, now I channel that inner 7th grade self and I figure out and I remember how to solve a two-step equation. I first move this. This is plus 5. So this becomes 2x equals 5. I then divide by 2 and I have x equals 5 over 2. That's one of my zeros. Okay, next one, I'm going to go ahead and grab this one. I'm going to bring it over here. This is going to be x plus 6 equals 0. My first step is I'm going to move this 6 over. This becomes negative 6. So x equals negative 6. There's no dividing or multiplying, so therefore that equals 0. Now, if you look at problem number 3 first starts off that it's not in factored form. So now we have to go back to unit 6B and we remember factoring A, B, C. My A value here is 1. My B value is negative. That's why I have pens with erasers. Is negative 12. And my C value is 27. I do my X. 27's on top. Negative 12's on bottom. I got to think of two numbers. When I multiply them together, give me 27. But when I combine them, give me negative 12. A negative times a negative is going to be a positive. One of the only factor pairs of 27 are 3 and 9. And 3 plus 9 is 12. So this is 3, this is 9. So this factored is x minus 3, x minus 9, and that equals 0. So now I'm back to this spot. So now I separate these out. This is x minus 3 equals 0. I move my 3 over. I'm supposed to change pen colors. I move my 3 over. This becomes positive 3. So this is x equals 3. That's one of my roots. The other one is x minus 9 equals 0. I add 9 over. I get x equals 9. So 9 is my other root. And one way I could check this if I wanted to is I could type this whole thing in and I could substitute this in. If I put in 3 right here, 3 times 3 is 9. 12 times 3 is negative 36 plus 27. 9 minus 36 plus 27, if I type that in Desmos, I would get a 0, which means that is my correct answer. Now, I want to look at problem number 4 and problem number 5. First, if we look at problem number 4, it says, what is the solution set for 3x squared plus 30 equals 21x? So the first question we have to ask is, what's different about problem number 4 compared to all the other problems that started before it? The first and obvious thing that you should have recognized and seen is that this is not set equal to 0. So I need to set it equal to 0. It's also not in standard form, so we can't factor it. So it's not in standard form. It's not in factored form. So we need to get it there. So the first thing we're going to do is move this 21 over. So this will become 3x squared minus 21x plus 30 equals 0. If you notice how I put that 21x right here in the middle, because that's my b value. But before I start factoring like I did in problem number 3 with my a, b, and c, I notice if I look at my a, b, and c, my a value is 3, my b value is negative 21, my c value is 30. All of those are divisible by 3. I'm going to want to divide that out. So I'm going to divide each one of these by 3. So this becomes 3x squared minus 7x plus 10. And here's the great thing about what we're doing right now. When we get to this factoring piece, when we factor this away and we get to this factoring piece, remember, we're going to have something like, I don't know, 3 times, I don't know, I'm just going to make up some numbers, 10, 2. Remember, we're trying to find when these values are 0. So do we even really care that there's a 3 out front? because 3 times 0 is still 0. It goes away. So the nice thing is we're doing this division piece, and in the end, it's not going to matter. It's just going to make our math at this part super easy. So now let's go ahead and identify our A, B, and C. Our A value here is 1. Our B value here is -7. Our C value here is 10. Okay, now what I'm going to do is I'm going to go ahead and do my X. 10 goes on top. -7 goes on bottom. Ooh, that's a terrible 7. The only two values that multiply to 10 but combine to 7 are -2 and -5. So my factored pair is 3x minus 2, x minus 5. Remember, I don't have to do the box here because my A value is 1. So I can skip that step on doing the box. Now I need all these pieces set equal to 0. So x, I started giving myself a parenthesis. I don't want to do that. X minus 2 equals 0. I would add 2 over. I get x equals 2. Here. This is x minus 5 equals 0. I add this 5 over. And this x equals 5. So my solution set is x equals 2 and 5. So that means here, if I were to plug in a 5 right here, actually I'm going to plug in a 2 because it's easier. This is 3, 2 squared plus 30. Well, 2 times 2 is 4, times 3 is 12. So this becomes 12 plus 30, which is 42. If I plug in a 2 here, 2 times 21 is also 42. So therefore, this is a solution because these are equal to each other. And if I plugged it in here, this would 0. And if I plugged it in here, it would still be 0. And if I plugged it in here, most importantly, 2 and most easy to see, 2 minus 2 is 0, which makes this entire thing 0 because of multiplication, because of the zero product property. That's how all of these things are tied together. You are trying to find the two, most likely 2, possibly 1 value that you could plug in for x that would solve this and make this true, that would make these two things equal, that would make this 0, that would make this 0, that would be a solution here, making it also 0. Now, number 5 decides to throw a word problem at us because who doesn't love word problems? It says the sum of the first n consecutive even integers can be found using s equals n squared plus n, where n is greater than or equal to 2. What is the value of n when the sum is 156? Listen to all of that garbage just to try and throw you off. Listen. What do you think the s value stands for? What's the word that starts with the letter s here? Sum. Sum. So when the sum is 156, this is our formula. Okay, I'm going to say 156 equals this, n squared plus n. Cool. Right now, thinking back to what we were doing, is it set equal to 0? No, it is set equal to 156. So let's go ahead and get it set equal to 0. I'm going to move it over. Instead of positive 156, it becomes negative 156. So n squared plus n minus 156. And by the way, do I care that my equal sign's on this side? No, I can just flip it over. It's equal. It's a balance. It can go on either side. Now, is this problem starting to look like this problem? Is it starting to look like this problem? Yes. Now what we need to do is we need to factor. So let's get our A, B, and C values going. A, B, C. My A value is 1. My B value is also 1. And my C value is negative 156. I do my X. Negative 156 on top, 1 on bottom. I need two numbers that when they are multiplied together give you 156. Okay? Now, I don't know that off the top of my head, but here's the other thing. They can only be separated by 1. So I know it's something not like 10, because 10 times 9 is 90, 10 times 11 is 110. I know it's not 11 because 11 times 12 is 121. I'm sorry, 132. So that's not going to work. But what will work is 12 and 13. And because this is positive 1, I'm going to have this one be the negative because 13 minus 12 is 1. 13 times negative 12 is negative 156. So this in factored form is x plus 13, x minus 12 equals 0. Now this looks like this, and it looks like this, and it looks like this, and it looks like this. Now we're just solving. We've factored, we've done the hard part, this is the easy part. X plus 13 equals 0. I move the 13 over, it becomes, let me switch colors again, x equals negative 13. Same thing here, x minus 12 equals 0. I move the 12 over, it becomes positive 12. I get x equals 12. So my solutions here are negative 13 and 12. This is the one time where I have to go back to the problem because the problem says something incredibly important here. The problem says the sum of the first n consecutive even integers can be found using s equals n squared plus n, where n is greater than or equal to 2. So here's the two things I'm going to point out. Even integers and greater than or equal to 12, or greater than or equal to 2. So therefore, negative 13 is not greater than 2. Negative 13 is not an even number. So therefore, based on the story part of this problem, this one doesn't work. Based on the story part of this problem, this works. So x equals 12 is my answer. Because it has to be positive, because it has to be even. Okay, so big recap. This is the key part in today. All of this other stuff, this is from previous units coming back to us. This part is what we're focused on. Solving our factored forms for 0. Set it equal to 0 and solve. Move something over, possibly have to factor and solve. Factor and then solve. Understand the story, manipulate, so in that way we're set equal to 0, factor, then solve. And that is how we solve quadratics by factoring.